Yeah. Good evening, children. Good evening, online students.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening.
Good evening.
Good evening. All right. So continuing with trigonometry. Yeah, this is the first question for today's class. Take it down. Online students, I've shared my screen. It's visible, right?
Yes, ma'am.
Yeah. A sine theta. Yeah. If x is equal to a sine theta plus b cos theta. So we are given an expression for x and y. X is given by a sine theta plus b cos theta, and y is given by a cos theta minus b sine theta. Now we need to prove that x square plus y square is equal to a square plus b square. So that is the left hand side x square plus y square is equal to the right hand side a square plus b square is what we have to prove. So let's take the left hand side LHS x square plus y square. Let's work that and we need to arrive at this result a square plus b square. The LHS is x square plus y square, which is nothing but this is x square. This one is x, so this is x square plus this is y square. This is x. This is x square plus this one is y square. Correct? So then they look like a plus b the whole square and a minus b the whole square. So you just have to expand using the formula identity and you get it very easily. So see it here. See it here. So let's take up the left hand side. X squared plus y squared. X squared plus y squared. So x is given to be a sine theta plus b cos theta. A sine theta plus b cos theta. X squared. So squared plus y. Y is this one. Y squared. So now we'll expand this. The first one using the identity x plus y the whole square. Okay. Or a plus b the whole square. So you can see here a squared. This one, this term squared plus b squared plus 2 into a into b. I'll show you how it works. What is a squared? What is a squared? A sine theta the whole square, correct? A squared, look at the board. A sine theta the whole square. So there's nothing but a squared sine square theta, correct? A squared sine square theta, right? B squared. B square is b cos theta the whole square. So that's nothing but b squared cos square theta. And 2 into a into b. 2 into a. This is a term into b. This is the b term. So that is 2ab sine theta cos theta. 2ab sine theta cos theta. So when you expand this, you get these three terms. And when you expand this, again, a square plus b square minus 2ab. Because this is like x minus y the whole square, right? X minus y the whole square. So how do you expand x minus y the whole square? X squared. X squared. So this one squared. This one squared is here. Plus y squared. The second term. This one squared. It's here. Minus 2 into x into y. So minus 2 into a cos theta into b sine theta. So that will again be 2ab sine theta cos theta. 2ab sine theta cos theta. So this is just the first step. That is after this one is just expanding using the identities x plus y the whole square and x minus y the whole square. Now these two terms get cancelled, plus and minus. These two terms get cancelled. So we are left with 4 terms. We had 6 terms here. In this step, we had 6 terms. Now, after cancelling out these two, we only have 4 terms. We only have 4 terms. Now, in these 4 terms, you can either take out a square common or a square b square common or sine square theta cos square theta common. So see here, if you group this one and this one, a square is common. This one and this one, b square is common. Or you can also group the sine square theta term and this sine square theta term and this cos square theta term and cos square theta term. So basically there are 4 terms you want to group. You want to take out the common factor between two of them. There are 4 terms you want to take out the common factor. You want to take 2 at a time and take out the common factor. So which 2 to group? You can either group this one and this one because they have a square in common, and this one because they have b square in common. Or you can also group this one as sine square theta. This one also has sine square theta. You can group these two, and this one have cos square theta. So you can group this one and this one, take out sine square theta common, this and take out cos square theta common. That way also you will get the result. So I have grouped these 2 terms because they have a square in common, and so you understand this. And between these two, b square is common. You get this in the bracket. Then write out this one, sine square theta plus cos square theta once. Okay, so this is nothing but, okay, what I have done is, what I've done is sine square theta plus cos square theta is 1, right? By the identity, sine square theta plus cos square theta is 1. Here also identity, sine square theta plus cos square theta is 1. So a square into 1 plus b square into 1. Sine square theta plus cos square theta is 1. So a square into 1. And this is also 1, b square into 1. That's what you see here. So what is a square into 1? A square. B square into 1? B square. So we proved that x square plus y square is equal to a square plus b square. You can, I meant you can also take out that you normally write this one, no, in one bracket. So you can write sine square theta plus cos square theta in one bracket. And then in the other bracket, what should you write? A square plus b square, a square plus b square. Now what is sine square theta plus cos square theta? 1. So 1 into a square plus b square, which is again a square plus b square. Yeah. Now take this down, children. I'm including one step. Please write that also. You should sit there. Yeah, you can sit there with your friend, I said. Done, online students? Finish writing this one?
Just a minute, ma'am.
Okay, okay, sure. You're able to see the board, right? I'm not in the way. You missed one class one, Dileepan. You saw the recording. Have you written the contents in the book? Sorry? One more? Some. No, you have to finish what? One more? Others you have written. Okay. Done, children? Online students?
Completed.
Yeah. So in this one, if x is equal to a sine theta and y is equal to b tan theta, prove that a square by x square minus b square by y square is equal to 1. So we're given expressions for x and y. Now tell me, what is x by a equal to? What is x by a equal to? X is given to you, right? Yeah. X is given to be a sine theta. What is x by a? Sine theta. Then what is a by x? 1 by sine theta. So what is a by x? It's nothing but cosecant theta. Cosecant theta. And what is a by x the whole square? A square by x square is equal to cosecant square theta. Cosecant square theta. So we got what is a square by x square. Now y is equal to b tan theta. Correct? What is y by b? Tan theta. Or you can, okay. So what is b by y? 1 by tan theta. So b by y is nothing but cot theta. No, 1 second. Let me write. We have to find out. We have to find oh yeah, b by y, no, right? Okay, y by b is tan theta. B by y is, oh yeah, I've written it already. Okay, so b by y is equal to cot theta. So when you square it, b by y the whole square is equal to cot theta the whole square, which is cot square theta. Correct? So b square by y square is equal to cot square theta. Now what should you find? A square by x square minus b square by y square. That's nothing but cosecant square theta minus cot square theta, which is 1. Which is 1. Correct? Yeah, write down. Write down, children. Finished? Finished online students? Completed writing online students?
1 minute, ma'am.
Okay, okay.
Completed, ma'am.
Yeah. Okay, so here if sine theta plus cos theta is equal to P, secant theta plus cosecant theta is equal to Q, show that Q into P square minus 1. So we know we have an expression for Q. We also have an expression for P. So you need to take up the LHS, which is Q into P square minus 1, substitute the expressions. And when you work that, you must get the RHS as 2P. That is when you work that, the result should be 2P, which is the RHS. Take it down. Take down the question. Yeah, I think this one you can help yourself. Very simple. Try to help yourself, online students. This is 2 sine theta cos theta. I made a mistake in typing here. This one is what, children? A square plus B square plus 2AB, right? So this plus should not be here. Typing mistake. A square plus B square plus 2AB. 2 into sine theta cos theta. Here also, this plus I've typed by mistake. 2AB, 2 sine theta cos theta. No, since I've missed a few steps, I just want to explain this. Sorry. Yeah. Children, please listen to me. So we first substitute. First step is to substitute. And after that, secant theta plus cosecant theta as it is. Expand this sine theta plus cos theta the whole square. Expand it. So you get a square plus b square plus 2ab. 2 into sine theta into cos theta. And that minus 1 as it is. Now we know that sine square theta plus cos square theta is 1. So in the next step, secant theta plus cosecant theta as it is. In the bracket, sine square theta plus cos square theta is 1. So 1 plus this one as it is 2 sine theta cosecant theta minus 1. Now plus 1 minus 1 gets cancelled. Okay, so here you have only one term, 2 sine theta cosecant theta. You have only one term. See, like if you have a plus b and into a here, we normally write a into a plus b like this, right? Simply because we're used to that, that's all. See now, when you have a plus b into a, you write that a, you tend to write that a first and then a into a. That's what I have done. There's no big like important step or something. I've just written in the front. So this single terms 2 sine theta cosecant theta, the single term, I've just put it in the front, 2 sine theta cosecant theta. And this one behind. I've just put it like that just to look so that it looks comfortable. So I've just put this one in the front, 2 sine theta cosecant theta into secant theta plus cosecant theta. Then 2 sine, this one has this 2 sine theta because other ratios only we change to sine and cos. So if the sine cos, have it as it is, 2 sine theta cos theta as it is. Secant is 1 by cos, cosecant is 1 by sine. Then LCM, common denominator, sine theta cos theta is a common denominator. So then you get in the numerator sine theta plus cos theta. Now sine theta, cos theta gets cancelled. And the result is 2 into sine theta plus cos theta. The result is 2 into sine theta plus cos theta. But sine theta plus cos theta is p. So that's nothing but 2p. 2p, which is the RHS. All right. Write down carefully, children. Done, children?
Completed, ma'am.
Yeah. This also simple. You can help yourself. And this recall this identity for you. What is a plus b the whole square? What is a plus b the whole square plus a minus b the whole square? And what is a plus b the whole square minus a minus b the whole square? Complete these two identities. A plus b the whole square plus a minus b the whole square is what? 2 into? Very good. 2 into a square plus b square. 2 into a square plus b square. And the next one? 4ab. Yeah, 4ab. 4ab. The next one is 4ab. Okay. Yeah, now try this. Completed? Okay. Yeah, so sometimes what happens, you need to work both the LHS and the RHS and show that they have the same result. That way also you can prove that the LHS is equal to the RHS. You can take up the LHS, work it, get a result. Take the RHS also and work it and get the same result. So when the LHS and RHS produce the same result, then also you verified whatever is given. So that's what we do here. So we take up the LHS, m square minus n square. We substitute, this is m square minus this is n square. So clearly it's of the form a plus b the whole square minus a minus b the whole square. So by the identity, it's 4ab, 4 tan theta sine theta. 4ab, 4 tan theta sine theta. Okay, I've just called this result 1. Now I take up the RHS. RHS is 4 root mn, 4 square root of mn. So 4 into square root of, this is m, this is n. So substitute m and n. All right. So now we have to continue working, right? So what is the change you will do? You will write other ratios in terms of sine and cos. Correct? So, okay. So you can do that here, or you can have multiplied and then change it. So this is like a plus b into a minus b. So a square minus b square. So tan square theta minus sine square theta. So now in order to continue, change tan square theta to sine and cos. Sine square theta by cos square theta. After substituting 4 square root of m into n. After this, this is like a plus b into a minus b, which is a square minus b square. Tan square theta minus sine square theta. Now we need to continue. So we write tan in terms of sine and cos. So tan square theta, sine square theta, because tan theta is sine theta by cos theta, sine theta by cos theta. Now square this on both the sides. So you'll get tan theta the whole square is equal to sine theta by cos theta the whole square. So which means tan square theta is equal to sine square theta by cos square theta. Tan theta is equal to sine theta by cos theta. Tan square theta will be sine square theta by cos square theta. Tan cube theta is cubing on both the sides. So again, tan theta is equal to sine theta by cos theta. You can cube it on both the sides. So when you cube on both the sides, in fact, you can raise both the sides to any power. You can raise both the sides to any power. So if you raise it to the power 3, then you will have tan cubed theta is equal to sine cube theta by cos cube theta. This is true, but the identity sine square theta plus cos square theta is equal to 1. That you cannot interpret as sine cubed theta plus cos cubed theta is equal to 1. You show it. How will you get this? Are you squaring on both sides, cubing on both sides? What are you doing? How can you write? This is true. This we have derived. But this one, simply, you cannot say, no, I just remove the squares and put 3 there. That you cannot do. See, now here we have proved, no? From tan theta is equal to sine theta by cos theta. We squared on both the sides. So you get tan square theta, sine square theta by cos square theta. All of us agree this. If you cube on both the sides, you'll get tan cubed theta is equal to sine cube theta by cos cube theta. This is true. But the identities you cannot change, like sine square theta plus cos square theta is 1. You cannot remove the 2 and say sine cube theta plus cos cube theta is 1. That's wrong. So tan is tan square theta, sine square theta by cos square theta. And then whenever there's something common, you always take out the common factor. So sine square theta is common in the numerator. Sine square theta is common in the numerator, so bring it out. So 4 is already outside the square root. Square root of 4 into square root of, in the square root, that is under the square root, sine square theta is common. So open bracket and 1 by cos square theta minus 1. Okay. So now LCM, 1 minus cos square theta by cos square theta and 1 minus cos square theta sine square theta by cos square theta So now square root of sin square theta by cos square theta is sin theta by cos theta. And now 4 by sin theta, sorry, 4 by cos theta is tan theta. Because you need to get the result as 4 tan theta sin theta. 4 tan theta sin theta. We have got 4. Now the sin by cos is tan. The sin by cos is tan. So 4 tan theta sin theta. This one, sin theta by cos theta. This one, sin theta by cos theta is tan theta. So 4 tan theta into sin theta. 4 tan theta into sin theta. See, this one is nothing but 4 into sin theta by cos theta into sin theta. Into sin theta. This one, this after this. 4 into sin theta by cos theta into sin theta. So 4 into sin theta by cos theta is tan theta into sin theta, which is the same as we got. Sorry. No, whatever one order you have here. 4 tan theta, any order, yeah. If you had written it as 4 sin theta tan theta, so 4 sin theta tan theta, any order. Yeah. So here also we got in the left hand side, we got 4 tan theta sin theta. RHS also we're getting the same thing, 4 tan theta sin theta. So this one is equal to this one, hence verified. So identities make our job easier. So here you should use the identity a plus b the whole square minus a minus b the whole square is equal to 4ab. 4ab. And then here it is a plus b into a minus b is a square minus b square. And then this tan square theta, we write it as sin square theta by cos square theta and then take up the common denominator. No, take out common because every time there's something common, take out the common factor. So sin square theta is common. So take it out. And then LCM. Again, because we are under the square root, we want perfect squares. We are under the square root, so we want perfect squares. 1 minus cos square theta, sin square theta. So now these two are perfect squares, sin square theta and cos square theta. So square root of sin square theta by cos square theta is sin theta cos theta. Any questions, online students?
No doubt.
All right. This also, I'll just tell you how it goes. So here it is like you have two equations. Listen to me, you have two equations. Okay, if x by a sin theta minus y by b cos theta is equal to 1 and x by a cos theta plus y by b sin theta is equal to 1. Prove that. Okay. So now it's like this. You treat the equations like this. Sorry. Okay. So what we're going to do is we're going to treat x by a and y by b as unknowns, like how you solve two linear equations in x and y, and you find the values of x and y. When you have two linear equations in x and y, you write them one below the other, and you use the elimination method, right? You make the coefficients equal. For the elimination method, you make the coefficients equal, and then you cancel out one of the variables, find the value of the other variable, and then substitute to find the value of the first variable, right? Do the same procedure here. You're going to treat x by a and y by b as the unknowns. And you're going to work like as if you're going to solve these two equations by the elimination method. Treat these two as equations as if they're linear equations. Treat them like that. And your variables are x by a and y by b. You're going to solve these two equations to find the values of x by a and y by b using the elimination method. So once you get the value of x by a and y by b, you can find out x square by a square plus y square by b square because you know the value of x by a. So you can find x square by a square. You know the value of y by b. So you can find y square by b square. Add both and you should show it's equal to 2. So we are basically going to write the equations one below the other and solve them by the elimination method. We're going to find the values of x by a and y by b. All right. Good. It continues on the next slide. Yeah, it doesn't end here, children. So normally you multiply the equations by some number, no? You'll multiply the first equation by 3, second equation by 5 to make the coefficients equal. Similarly, here we are multiplying the first equation by cos theta and second equation by sin theta so that they become equal. So see now in the first and second equation, after multiplying, you get this one and this one. So now they're equal. So you can change the signs and eliminate them like this. Yeah. Yeah. Yes. Second column. Huh? First column. Huh? No. See, we have minus. No. Sometimes it can be a typing error, but here it is not. Okay, so I'll tell you. So minus y by b cos square theta minus y by b sine square theta. This is what we have. Okay. So minus y by b is common. Okay. So in the bracket, you will have cos square theta minus outside. No, so minus into plus is minus. So sine square theta in the bracket. I'll write it neatly. 1 second, 1 minute. Let me not see here. So it's about this one gets cancelled, right? Yeah. So how to simplify these two terms? Let me write it here. See here. Minus y by b cos square theta minus y by b sine square theta. So minus y by b is common. In the bracket cos square theta minus into plus is minus. And y by b outside. So sine square theta here. So it's nothing but minus y by b cos square theta plus sine square theta. That's what I've written, sine square theta plus cos square theta. Okay, let me write cos square only first. Cos square theta plus sine square theta. Correct? Okay. Okay. Yeah, we have not finished, but we'll just see so far. So because it's similar to the elimination method, I think you understand. We multiply the first equation by cos theta and the second one by sine theta to eliminate x by a term. The x by a terms, like you eliminate x or y, no? So here we are eliminating the x by a term, x by a. So for that, we multiply the first one by cos, second one by sine. You can even eliminate y by b term. Multiply accordingly. If you want to cancel out the second term, y by b terms, you multiply with some other ratio accordingly. So here I've multiplied to eliminate the first term, x by a. All right. So I hope you all understood multiplication. We all got that right. One, see, when you multiply 1 into cos theta is cos theta, not 1. When you multiply the second equation by sin theta, 1 into sin theta is sin theta. All right. Okay. Write the equations one below the other, and you have to change the signs. You'll have to change the signs in the second equation. You'll have to change the signs in the second equation. That's what you see here. I've changed the signs. Then this one gets cancelled. And here it's minus y by b cos square theta minus y by b sin square theta. So I told you take out minus y by b common. So in the bracket, you will get cos square theta plus sin square theta, which I have written as sin square theta plus cos square theta is equal to cos theta minus sin theta. That's the first step. Now, like how you work to find the values of x and y. Here also we're trying to find the value of y by b. After finding y by b, we're going to substitute and find the value of x by a. We're trying to find the expressions for y by b and x by a. Okay, so now this one is 1. So minus y by b into 1 is equal to cos theta minus sin theta. But that's minus here. So take that to that is multiplying both the sides by the minus sign. The next step is multiplying both the sides by minus sign. Or minus 1. Multiplying both the sides by minus 1. Multiplying both the sides by minus 1. This one by minus 1, this one also by minus 1. So what will happen? Minus into minus plus y by b. This one is gone. This one sin square theta plus cos square theta is 1. Then y by b into 1 is y by b only. Multiplying both the sides by minus 1. So this becomes plus y by b. And here that minus sign outside. We've multiplied, so that minus sign outside. Then it becomes minus cos theta plus sin theta. Minus cos theta plus sin theta. When you multiply this one by minus 1, you should multiply this whole thing by minus 1. So that means the whole thing is multiplied. No? So minus 1, minus 1. Nothing but you're multiplying the side by minus sign only. Minus sign. Minus 1 is also the same. No, you'll get the same terms. So when you multiply minus into cos theta minus cos theta here, and minus into minus plus sin theta. So sin theta minus cos theta. Now we got the value of y by b. We're going to substitute in any one of the two equations and find the value of x by a. We found y by b. Now we're going to substitute y by b is equal to sin theta minus cos theta in any equation, 1 or 2. I have taken 1. 1 means don't take this one. Take the original one. So there you substitute. So I've written that equation. You can see here I've written that equation. And then substitute where you have y by b. No, use sin theta minus cos theta. That is y by b here. Instead of this, you say sin theta minus cos theta. So this x by a sin theta as it is. This one is sin theta minus cos theta. This one sin theta minus cos theta. So you can see here sin theta minus cos theta into cos theta. This one is sin theta minus cos. This is y by b, children. This is y by b. This is y by b into cos theta. But there's a minus sign outside. That's why a bracket is equal to 1. See, this x by a sin theta is here. This minus sign is here. And y by b is replaced with sin theta minus cos theta into cos theta is equal to 1. This whole thing has a minus sign outside. That's why I put a bracket. This whole thing has a minus sign outside. Now when you multiply, you will get sin theta into cos theta, sin theta cos theta. Cos theta into cos theta is cos square theta minus cos square theta. And finally, when you open this bracket, it will become minus sin theta cos theta minus into minus plus cos square theta is equal to 1. So remember, we're trying to find the value of x by a. We're trying to find the value of x by a. So I'm having only x by a term on one side and taking all the other terms to the other side. So you can see here x by a sin theta is equal to this one already here. Then transpose this one and this one. Transpose these two. So you'll get 1 minus cos square theta plus sin theta cos theta. Now what is 1 minus cos square theta? Sin square theta. So you should write sin square theta. And then you will have sin theta common. You can continue now. 1 minus cos square theta is replaced with sin square theta. Sin square theta. Then sin theta common. Then they get cancelled on both the sides. So x by a is equal to sin theta plus cos theta. Yeah, continue, children. Please continue. Finished? Finished? Online students? Completed this one?
Yes, ma'am.
Okay. All of you? Rajat?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. All right. So we stopped here. So 1 minus cos square theta is replaced with sin square theta. And then between these two terms, sin theta is common. So bring it out. So sin theta into sin theta, sin square theta. And sin theta into cos theta, sin theta, cos theta. Then what happens? Sin theta on either side gets cancelled. Because the sin theta, when it comes here, it will come for division, no? Sin theta by sin theta. So they'll get cancelled. So you can cancel that here itself. They get cancelled. So x by a is equal to sin theta plus cos theta. Now we need to work x square by a square plus y square by b square and show the result is 2. So we already found x by a here. What do we find here? Y by b. Okay. We already found y by b here. And now here we have x by a. So x by a the whole square plus y by b the whole square is equal to sine theta plus cos theta the whole square plus sine theta minus cos theta the whole square. Substitute the values. So now you can use identity here. What is a plus b the whole square plus a minus b the whole square? 2 of a square plus b square. A plus b the whole square. This is like a plus b the whole square plus a minus b the whole square. Sine theta plus cos theta the whole square plus sine theta minus cos theta the whole square. A plus b the whole square plus a minus b the whole square is equal to 2 of a square plus b square. 2 into a square plus b square. And we know that sine square theta plus cos square theta is 1. So 2 into 1, 2. So we need to treat these two equations like as if they're linear equations in two variables, x by a and y by b. X by a and y by b. We need to write the equations one below the other and cancel out the terms that have x by a by multiplying the equations with an appropriate ratio, or cancel out the terms containing Aishwarya, sorry, Ananya, oh no, what's your name? Madhumita, sorry. Y by b, yeah. So you need to cancel out, you need to work this as if you're solving two linear equations by the elimination method. You need to eliminate the terms that contain x by a or eliminate the terms that contain y by b by multiplying the two equations by a suitable ratio. You can multiply the first equation by a ratio and the second equation by a different ratio, of course. And when you're multiplying, be careful when you multiply one, meaning the first ratio, first equation by cos theta, 1 into cos theta is cos theta. And the second one by sine theta, 1 into sine theta is sine theta. Don't write 1 by mistake. You wrote 1? No, like, did you write 1 and then strike it out and write? Anybody here wrote 1 and then strike it and wrote sine theta, cos theta? No. Okay, so then again, after that, you need to check if you have to change the signs or not change the signs. So here you have to change the signs. Only then they get eliminated. And then how do you find y by b? You must take out y by b common. Only then you can find y by b. There should be y by b only in one place. If you want to find the value of y by b should be in only one term. If you have y by b in two different places, you cannot find y by b. You should take out y by b common, make it appear in only one place. There should be only one y by b. Y by b should not be in more than one term. Y by b something, y by b something, y by b. No, there should be only one y by b. Then only you can find y by b, which is why we take out this one common, minus y by b common, and you get these terms in the bracket. And cos theta minus sine theta. So like that you find y by b, and be careful with the minus sign. When you multiply both the signs, so here we, when you take this minus here, it's like you're multiplying both the sides by -1. Multiplying both the sides by -1. Okay, so finally we find y by b. So then we substitute in one of the two equations to find x by a. So that substitution at this part here. Yeah. So after substituting, you should have x by a in only one place. Okay, x by a is only in this term, x by a. But you should have it alone on one side, and you should take the remaining terms to the other side. Only then you can find x by a. If you want to find x by a should be in only one term, and it is already only in one term, x by a sine theta, that's all. Now the other thing is, the other condition is the rest of the terms must be on the other side. That's why we transpose, we take everything. We have only x by a sine theta on one side, and we take everybody else to the other side. All of them we take to the other side. Only then you can find x by a. Only that x by a term you should have on one side. The rest of them take to the other side. Now 1 minus cos square theta is replaced with sine square theta. Sine square theta. Now of course sine theta is common, so we get this in the bracket. Sin theta gets cancelled. And so x by a is equal to sin theta plus cos theta. So now we have found, like we find the values of x and y. Here we have found the expressions for x by a and y by b. Now substitute. Now take up this LHS. We know x by a and y by b. Work this and show that the value is equal to 2. So identity save your time actually. Identity save your time. Otherwise you'll take like 1 or 2 minutes extra to write the 2-3 steps when you expand. All that matters in the exam. Now you have time to write, you will write it. But in the exam, every 1 or 2 minutes matter. So this one, if you know the identity, a plus b the whole square plus a minus b the whole square is equal to 2 of a square plus b square. Otherwise, you'll be expanding and then you'll have to cancel, then simplify. So you take a little more time. But like that, if you save 1-2 minutes here and there, you can like save some 10-15 minutes, which really matters in an exam. So remember these identities, they're very useful. So 2 of a square plus b square, and this one is 1. Sin square theta plus cos square theta is 1. So we proved that it's equal to 2. Children, any more questions? Online students, please ask me. Here, children. Yeah, take down this one. It's similar to one sum we did earlier. Some, I think the second one. Yeah, the fourth one. It's similar to this one. It's similar to this one. See, like when you square this one on both the sides, you will get m square minus n square the whole square is equal to 16mn. This is nodding. Here, when you square this one on both the sides, what will you get? M square minus n square the whole square is equal to 16mn. I think that's what we have to prove here. Yeah. Similar to that one. Like this. Done writing, Arjun? What question paper, huh? Finished, all of you? Online students, done writing?
Yes, ma'am.
Okay. Yeah, this is also similar. We had one P into Q square minus 1. No, let me just check that. P into Q square minus 1 we had. Yeah, this one. So this one is sine theta and cos theta. Sine theta, cos theta, secant and cosecant. This one is. This one is. Is it the same then? Please check. Just that the letters were different, I think. Then we had P into, here we have M and N. Just check. The same, no? No, MN is PQ. Where then? What's the difference you are spotting, Raja? Secant theta plus cosecant theta. What have you written? Cosecant theta only. See the previous one, this is. Secant theta plus cosecant theta. You have written cos all the way, is it? Oh, change it. Okay, we'll skip this one. Not this, sorry. Yeah, this one will skip. Yeah, take down this. Okay. Now, whenever this M and N, no, the expression is given. See, okay, I'll tell you the difference. Just a second. I have to take you to the earlier ones. 1 second. See here, now this is, what is M? Tan theta plus sine theta. And what is N? Tan theta minus sine theta. So we did not change anything. Like we didn't write, we didn't do any change. We just got started like that because when you apply, when you substitute this, it'll be like A plus B into A minus B. So we could do A square minus B square or some identity. Because one is A plus B and the other is A minus B. We use identities, right? A plus B the whole square minus A minus B the whole square is 4AB and all that. See, when these expressions are not related, like in this one. When the expressions are not related, like in this one, M is cot theta plus tan theta, N is secant theta minus cos theta. See, like if M is tan theta plus sine theta and N is tan theta minus sine theta. If M is tan theta plus sine theta, N is tan theta minus sine theta. then even if you don't make any changes, you can still do it because it looks they're like a plus b and a minus b. So you can use some identity and proceed. But look at these expressions here for m and n. They're not related at all, right? Meaning one is cot theta plus tan theta, the other is secant theta minus cos theta. So we'll simplify whenever. So when they're not related like this, we'll first start by simplifying. Simplifying meaning m is equal to what? Don't write, children. We'll listen first and then write. See it? What is m equal to? M is equal to cot theta plus tan theta. I'll change cot to tan and also everything to sine and cos and work and show that you get the same thing. Okay, so first I'll change it to sine and cos. So that is equal to cos theta by sine theta plus sine theta by cos theta. That is equal to common denominator sine theta cos theta. So cos square theta plus sine square theta. That's equal to 1 by sine theta cos theta. This is m. This is m. Now supposing you do it like this. Supposing you do m is equal to cot theta plus tan theta. That is equal to 1 by tan theta plus tan theta. Supposing you can also do this. Okay, so that is equal to tan theta is a common denominator. So 1 plus tan square theta. 1 plus tan square theta. 1 plus tan square theta is secant square theta. Secant square theta by tan theta. Now, see here, it is secant square theta divided by tan theta. See, we are working not to complicate the expression, but to simplify the expression. So you don't leave it with secant square theta by tan theta. You're not working to make it more complicated. You want it simpler. Simpler means you want it in sine and cos. So don't stop there. So secant square theta divided by tan theta. What is secant square theta? 1 by cos square theta divided by sine theta by cos theta. Sine theta by cos theta. So division becomes multiplication and reciprocal into cos theta by sine theta. Now that cos theta and cos theta will get cancelled, right? This cos theta and this cos square theta, they get cancelled, correct? Yeah. So what do you get? So m is equal to 1 by cos sine theta cos theta or cos theta sine theta. So anyways, you'll get this result. You can change cot and tan to sine cos or like this. You can also have cot theta as it is and change tan theta to 1 by cot. So then you will get 1 plus cot square theta. So you will write that as cosecant square theta. So when you have tan and cot, you have many options. Either you can change both tan and cot to sine and cos. That's one. Otherwise, when you have tan and cot, have tan as it is and change cot. Write it as 1 by tan. Or have cot as it is and write tan theta as 1 by cot theta. Everything will give you the same result. Now what is n? N is equal to secant theta minus cos theta. What is secant theta? 1 by cos theta minus cos theta. Common denominator. So 1 minus cos square theta by cos theta. What is 1 minus cos square theta? Sine square theta by cos theta. So simple meaning, we have simplified meaning we got it on sine and cos. That means it's simple now. When you bring it to sine cos, it is simple. Okay, so now we got m is what? 1 by sine theta cos theta and n is sine square theta by cos theta. So what I'm trying to say is when those expressions for m and n, when the expressions for m and n, they are like a plus b into a minus b, then even if you don't do any changes, you can work comfortably because they'll fit into some identity. Like we just used some identities, right? A plus b the whole square plus a minus b the whole square is 2 of a square plus b square and all that. If they're completely different, m is something, n is something else, then you should always simplify those expressions and then proceed. Before you substitute in the LHS, you must simplify them and then substitute. Am I clear, children? Okay, so now we have simplified, no? What is m? What is m? 1 by sine theta cos theta. And what is n? Huh? Sine square theta, is it? Okay, by cos theta. Okay, now we need to take up the LHS and substitute all this. Now we need to take up the LHS, substitute. You can see here, I've worked here. You can see here, what we just understood is here and here. Is here and here, is here and here. Now let's understand this part, children. Let's understand this part now. So now we take up the LHS. Okay, we take up the LHS, this one, and we need to substitute. What is m? What is m? See, I've substituted m. This is m squared, and this is n. This is m squared and n. The whole power 2 by 3. You can. This is the whole power 2 by 3. This is 2 by 3. Online students can see it, but I think for you, is it clear? I'll zoom it later. Okay, it's clear. Okay, fine. This is m square n, and the whole power 2 by 3 is here. Minus mn square. m n square. The whole power 2 by 3. 2 by 3. So we just substitute. All right, substituting the expressions for m and n. All right, now square this. This one is m square, no, square it. So you will get 1 by sine square theta cos square theta. And here, okay. So here this is what? Any problem? Okay. No, I thought Madhumita is ragging you. Okay. So, you sure? Cold? Okay. All right. So this one squared and this sine square theta by cos theta as it is, the whole power 2 by 3. 2 by 3 minus this one as it is. Here you'll have to square this. This one is squared. So sine square theta, the whole square, is sine theta to the power 4. Sine theta to the power 4, like a square, the whole square is a to the power 4. So like that, sine square theta, the whole square is sine theta to the power 4. And cos theta, the whole square is cos square theta. The whole power 2 by 3. The whole power 2 by 3. Now cancel. Sine square theta cancels. Then here also one sine theta and this one. So sine cube theta will remain here. Correct? So here what happens? Cos square theta into cos theta is cos cubed theta. Cos square theta into cos theta is cos cubed theta. Like a square into a is a cubed. Okay. So 1 by cos cube theta, the whole power 2 by 3. The whole power 2 by 3. Minus, in the numerator we have sine cube theta. Denominator, no, you should, 1 minute, just come forward, no? He has no. Yeah. Yeah. So sine cube theta by, in the denominator, cos theta into cos square theta is cos cube theta. All right. So I said, I think I finished this step. So now it looks like this. Now, how do you simplify when you have powers, children? When you have a cubed, the whole power 2 by 3. In exponents, what we do? When we have many powers, we multiply the powers. When we have many powers, we multiply the powers. See, like when it's a cubed, the whole power 2 by 3, we work like a to the power 3 into 2 by 3 like this, and 3 and 3 cancels and a square. When the base is raised to many powers, we multiply all the powers. That's what we do here also. So I've written this 1 by cos theta, this power 3 into 2 by 3. Multiply the powers. See here, 1 by, the power is 3, right? So 3 into 2 by 3, 3 into 2 by 3. Multiply the powers. So 3 and 3 will get cancelled. 3 and 3 will get cancelled. And then you see a square here. So 1 by cos theta, the whole square. 1 by cos theta, secant theta, the whole square, which is secant square theta. And here, sine cube theta by cos cube theta. You can even write this as tan cube theta, children. You can even write this one as tan cube theta in the next step. In the next step, sine cube theta by cos cube theta is what? Tan cube theta. And it is tan cubed theta, the whole power 2 by 3. So it will be tan theta, the whole power 3 into 2 by 3. So 3 and 3 will get cancelled. Tan theta, the whole square is tan square theta. So secant square theta minus tan square theta, which is 1. Secant square theta minus tan square theta is 1. But that's what we have to prove. Prove that it's equal to 1. Yeah, take down, children. Done. Online students.
Completed, ma'am.
Okay. Let's just work this part again. Yeah. So tell me, what is M, children? I'm working the LHS. What is M? No, after that simplification. 1 by sin theta cos theta. So 1 by sin theta cos theta. M square into N. Sin square theta by cos theta. The whole thing is raised to the power 2 by 3 minus M. M is 1 by sin theta cos theta. M. This is M. N square. N is squared. Now both this is raised to the power 2 by 3. Both of these M N square, the whole power 2 by 3. Both of this is raised to the power 2 by 3. So we substituted. Next, 1 by sin square theta cos square theta. Correct? Then into sin square theta by cos theta. The whole power 2 by 3. Minus 1 by sin theta cos theta into sin theta to the power 4 by cos square theta. The whole power 2 by 3. So next what? Sin square theta gets cancelled. 1 by cos cube theta. Now we multiply the power. So we'll write 1 by cos theta and that cube, no, it becomes 3 into 2 by 3. Correct? 1 by cos cube theta. But we'll remove the 3n because we'll have to multiply the powers. So 3 cancels. So 1 by cos square theta, which is nothing but secant square theta. 1 by cos square theta, which is because cos theta, the whole square is cos square theta, which is secant square theta. 1 by cos square theta is secant square theta. Here, sin cube theta by cos cube theta. Sin cube theta by cos cube theta is tan cube theta. I told you we'll write it like that. Sin cube theta by cos cube theta is tan cube theta. So tan cube theta meaning you write tan theta. That cube, no, 3 into 2 by 3. So 3 and 3 will get cancelled. Tan theta the whole square, which is tan square theta. Secant square theta minus tan square theta is 1. All right? Yeah. Hence proved. All right. Online students? Can we go to the next one?
Yes, ma'am.
Okay. Yeah. You can do this by yourself. Use the identity. Use the identity. A plus B the whole square plus A minus B the whole square is equal to 2 of A square plus B square. Use this identity and in place of A, use cos theta and B sin theta, right? Finished? Got it? Probably you will get square root of 1, which is plus or minus 1. Square root of 1. So plus or minus 1. No, maybe you get something is equal to square root of 1. So like square. Okay. Not getting, is it? Okay. All right. So, okay. So cos theta plus sin theta, the whole square, correct? Plus cos theta minus sin theta, the whole square, correct? Is equal to 2 of cos square theta plus sin square theta, because a square, b square. So is this right? Now this one is 1. Cos theta plus sin theta is 1. So 1 square plus this one only we have to find. Cos theta minus sin theta, this we have to find, or we'll have to prove something. So this will come as is equal to 2 into 1. Because cos square theta plus sin square theta is 1. Sin square theta plus cos square theta is 1. Identity. So now cos theta minus sin theta, you should not expand this. The whole square is equal to 2 into 1, 2 minus 1, transpose. Minus 1, because you're working to find this one, right? So you must take everybody else to the other side. So we get cos theta minus sin theta. The whole square is 1. So cos theta minus sin theta is equal to the square root of 1, which is plus or minus 1. All right? Yeah. Right, Anchalan? After substituting, what did you do? Oh. Which means you expanded cos theta minus sin theta the whole square, is it? Okay, okay. Okay. You didn't try to find the value. You just brought everything to one side. Okay. Now here, okay, you finish it. I'll tell you why we should not use the other identity. I'll tell you that here. Understood, right? So cos theta minus sin theta, the whole square is 1. So cos theta minus sin theta is equal to plus or minus the square root of 1. So plus or minus 1. Okay. So when you use this identity, so this one is going to be, this one we have the value cos theta plus sin theta, we have the value 1. Cos theta minus sin theta, we have to find. On this side, if you use 4ab, just compare using 4ab and using this one. When you use 2 of a square plus b square, this also you will find the value. This value is 1. See, we have 3 expressions, of which you should know 2 of them. We have 3 expressions, 1, 2, 3. We have to find this one. We have to find this one. That means you need to know the value of this. This is 1 because it's given in the question itself. And this also you should know the value. This one is also 1. See, whenever there are 3 expressions in an equation, you should know the values of 2 of them. Only then you can find the third one. You know this. In any equation, when you have 3, when there are 3 unknowns, you should know the values of 2 of them. Then you can find the third one. So when you use 4ab, it will be 4 sin theta cos theta. Yes or no? But when you take this identity is 2 of a square plus b square, where that a square plus b square is sin square theta plus cos square theta, which is 1. So you prefer to take this identity over this one. So to work, see, this one looks like a plus b. This one looks like a minus b. So it's easy to identify that we have to use this identity. This is a plus b, this is a minus b. So a plus b the whole square plus a minus b the whole square is equal to 2 of a square plus b square. So in place of a, use cos theta. In place of b, sin theta. That's it. One minute. I just want to see how much is that. Yeah. Yeah, this one, no, I'll just send a picture. You can help yourself. I'll send a picture. We'll just do something else. Leave some, copy the question and leave some space. Leave some space for this one. You can finish it at home. I've shared the answer on WhatsApp. Let's do this one. Okay, so these are standard questions, children. If you get it, it will be like this without any changes. These are standard questions. It will be asked as they are here. So I'll give you a few more questions which resembles this one. So you will understand that this pattern has to be tried like this. Now here what you'll have to do is take up what is given. If 2 sine theta don't work, plus 3 cos theta is equal to 2. This is given to us. This is given to us. But we need to show that 3 sine theta. See, we have here 2 sine theta. But in the result, we have 3 sine theta. And here we have 3 cos theta, but there it is 2 cos theta. The numbers are exchanged, no? Here for sine theta, we have 2. But in the result, okay, see this. Sine theta it is 2. But here for sine theta it is 3. Cos theta it is 3. And here it is cos theta 2. What you have to do is square this on both the sides. Something is given to you, right? Something is given to you. 2 sine theta plus 3 cos theta is equal to 2 is given to you. Take that. Square on both the sides. Square on both the sides. So that will give you 4 sine square theta plus 9 cos square theta plus a square plus b square plus 2ab. 2 into 2 sine theta into 3 cos theta. So 12. 12, right? 12 sine theta cos theta is equal to 4. Correct? At this stage, what you should do, you must replace sine square theta with 1 minus cos square theta and cos square theta with 1 minus sine square theta. That's all. If you do this now blindly work, you will get the result. You must replace the sine square theta with 1 minus cos square theta and cos square theta with 1 minus sine square theta. Identically. That's it. Now the coefficients will get exchanged. Because for sine you have used cos and here for cos you have used sine. So the coefficients will now be exchanged. That's all. You must just write down what is given and square that on both the sides. And when you get sine square theta and cos square theta, replace sine square theta with 1 minus cos square theta, cos square theta with 1 minus sine square theta. That's it. You're done. Now tell me 4 minus 4 cos square theta plus 9 minus 9 sine square theta, opening the bracket, plus 12 sine theta cos theta is equal to 4. Now numbers, we'll simplify the numbers. 4 plus 9, 13, right? 13. So we'll take the 13 to the other side. So it will be minus 4 cos square theta minus 9 sine square theta plus 12 sine theta cos theta is equal to 4 minus 13. So now it will be minus 4 cos square theta minus 9 sine square theta plus 12 sine theta cos theta is equal to minus 9. Now we'll change the signs throughout on both the sides. We'll change the signs on both the sides. Why should we change the sign on both the sides? Because see, this is a square, but it's minus 4 cos square theta. And this is b square, but it's minus 9 sine square theta. You want you want plus a square plus b square and maybe minus 2ab. The 2ab term can be plus or minus, but your a square and b square, you want them to be positive, right? The a square and b square term, you want it positive. The 2ab can be positive or negative. 2ab can be positive or negative. But here, see this cos square theta term. Cos square theta term, and that is the terms the terms that represent a square and b square are negative. No, you don't want that. You want them to be positive. That's the reason why we change the signs on both the sides. So then we get 4 cos square theta plus 9 sine. That is minus becomes plus. Plus becomes minus. So Krishmi, is it plus sign plus 12 or minus 12? Minus 12. Sine theta cos theta is equal to, change the signs on both the sides, plus 9. Now see, you want 3 sine theta first, no? So you write this 9 sine square theta first. 9 sine square theta plus 4 cos square theta minus 12 sine theta cos theta is equal to 9. Now this is like 3 sine theta, the whole square, plus 2 cos theta, the whole square, minus 2 into A into B is equal to 9. A square plus B square minus 2 into A into B. So what is that? It will be A minus B the whole square, because minus 2AB. A minus B the whole square. So it will be 3 sine theta minus 2 cos theta the whole square, because we have A square plus B square minus 2AB. So A minus B the whole square is equal to 9. Is equal to 9. So 3 sine theta minus 2 cos theta is equal to square root of 9, but plus or minus square root of 9, which is plus or minus 3. So you should register this question in your mind, this pattern in your mind, and you must remember that rule. That's all. It's like a question and answer. If you see this kind of a question, then the rule is write what is given, square on both the sides, then that A square, B square terms, no, you have that sine square theta, cos square theta, those terms. You should write sine square theta as 1 minus cos square theta and cos square theta as 1 minus sine square theta. That's all. Once you write that, then you'll have to open the brackets, multiply and open the multiply to open the brackets by multiplying. That's all. The numbers you should take to the other side. And if your A square and B square terms are negative, you should make them positive. So then you will have to change the signs throughout. That's all. Yeah, take it on, Jim. Please take the answer. Okay, here I've cancelled the 4 on both the sides. So it is the same, don't worry. Plus 4 and plus 4 gets cancelled on both the sides. So this 9 will become minus 9 here. Okay. Done? All of you? Finish writing? Online students?
Completed.
Completed, ma'am.
Very nice. Okay. All right, children. Yeah, so that's it for today's session. Thank you so much. Good night. Online students may leave the call. Thank you.
Thank you, ma'am. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you. Thank you, children. Good night. On Saturday,